Alright, welcome to Compound Interest Part 2. This video should be shorter. Let's see if I keep my promise. But the idea of this is, instead of solving for either my starting amount or my ending amount, I could solve for my interest rate or the amount of time passed if I know the other pieces of the puzzle. As long as you know 3 out of the 4 pieces, you're good. Now, I'm not going to make you do this with the other type of interest just because the math becomes disgusting very quickly, even when I was starting to do it. But this math really stays within what we've already done. It's just using natural logs, really. Alright, so let's get started. Antoinette invests $2,220 in a savings account with a fixed annual interest rate compounded continuously. After 7 years, the balance reaches $3,623.74. What was the interest rate on the account? So again, I'm going to start off just by defining my variables. So I want to know ending amount, starting amount, interest rate, and time. So we know that our ending amount was how much the balance reaches after 7 years. So that is $3,623.74. I like going from the variable, defining the information. If you want to start the information, you can then jump to the variable. For example, I could ask myself, what does this $2,220 mean? Let's read the sentence again. Antoinette invests $2,220 in a savings account. Ooh, that must be my starting amount. So that's $2,220. Also, if you want to check if you got them straight, your ending amount should be greater than your starting amount. We're not depreciating in value, we're increasing in value. All right, do I know my interest rate? I don't see no interest rate there, so I don't know that. Do I know the time though? Yep, 7 years. So let's go ahead and plug this into the equation. So I have A equals PE to the RT. So the A is $3,623.74. My starting amount was $2,220. E to the unknown R times 7. So I've got to try to get E by itself, just like we did with all of those E equations. They have a use. So we're getting E by itself. Okay, well, how do I get E by itself? Well, I got to divide both sides by what E is being multiplied by. So that's the 2,220. Let's go ahead and do that lovely division. So I do 3,623.74 divided by 2,220. So that's 1.63215 equals E to the R times 7. Now this is sort of backwards than I'm usually used to seeing. I'm usually used to seeing the E first. So let's go ahead and just rearrange it so E's first. E to the R7 equals 1.62315. Now we can go ahead and do first, last, middle. So first, natural log of last 1.62315 equals the middle, R times 7. I'm going to go and put multiplication so we remember that. So I just take the natural log of this guy, 0.4899994 blah 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 equals R times 7. Divide by 7 to still get by itself. Divide by 7. So I get my R is 0.069999, repeating. Which really just rounds up to, since we got so many 9s repeating, go ahead and just round up that 6, say it's 0.07. That's fine. So if you see a whole bunch of 9s repeating like that, just round it up. Alright, so let's rehash this because I did not show my work as neatly as I probably should have. So you just start off by plugging in your variables. Then if I know I'm trying to get something in the exponent by itself, I go ahead and sort of rearrange it like a normal E equation that I'm used to. Get my exponent by itself, rearrange it. Then do first, last, middle, natural log, so log base E of the last equals the middle number. Actually evaluate that natural log, get the variable by itself by dividing by 7, and then I get my rate. If you want to know what your rate is in terms of a normal rate, all you have to do is take your answer, multiply it by 100. So my rate, again, that 6.99999 repeating to infinity is basically the interest rate is 7%. There you go. Alright, go ahead and take a picture of this, write down on a separate sheet of paper, whatever it is you need to do. Alright, let's move on to the next example. Alright, I want you to pause the video and try this example entirely on your own. Alright, welcome back. We're going to go ahead and read our problem together. So Casey invests $3,345 in a retirement account with a fixed annual interest rate of 6% compounded continuously. How long will it take for the account balance to reach $8,736.12? So let's write down what we know and what we want to know. So do we know our ending amount? Absolutely. That's this big old number. This is what she is going to eventually reach. So that's $8,736.12. Do we know our starting amount? Yep, and that's the $3,345. Do I know my interest rate? Yes, I do this time. That's 6%, which as a decimal is 0.06. Do I know the amount of time, though? No, that's what I'm solving for. Which really, you notice they're in the same place in the problem, though. The way you solve for interest rate is the exact same way that you solve for time. So let's actually show that out, though. So then we get A equals PE to the RT. So then we get $8,736.12 is $3,345 to the E to the 0.06 times unknown T. Now, if you haven't already tried to solve it out already, now that I've set it up for you, pause the video and try to solve it out yourself. Alright, welcome back. So again, our goal is to get my exponent by itself so I can turn it into a log equation. So I go ahead and divide both sides by the number it's being multiplied by. And now this is the part where I get out my handy dandy calculator. Which again, you can use Desmos. I'm just showing you that even if you're being as low tech as what's already on your phone, you can still do this. $8,736.12 divided by 3,345. That gives me 2.611695 blah 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 equals e to the 0.06 times t. Again, I'm going to go ahead and just flip this guy around so that my exponent's first, just because that's what I'm used to seeing. E to the 0.06t equals 2.6 blah 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 blah. Alright. Now we're going to go ahead and turn this into a log equation so I can actually solve for it. So I get first natural log of last 2.611695 blah 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 equals 0.06t. So I'm going to go ahead and take the natural log of this guy, and I get 0.959999 going on 46. That's good enough, equals 0.06t. Divide by 0.06 to get t by itself. Divide by 0.06. And I get t is 15.99999 blah 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 going on to infinity. That rounds up to how many years? 16 years. So if you see again the 0.999 blah 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 blah, just go ahead and round it up. That's basically what it means. Now let's put it back into the context of the problem. How long will it take for it to reach that amount? It will take 16 years to reach $8,736.12. There's your beautiful sentence. All right, go ahead and take a picture of this or take down your notes, whatever you need to do, and then we'll move on. All right, next example. All right, I want you to pause the video and try this example entirely on your own. All right, welcome back. So let's go ahead and write this down. We got Tashawn invests $5,123 in a retirement account with a fixed annual interest rate compounded continuously. After 13 years, the balance reaches $14,494.08. What is the interest rate of the account? So let's go ahead and write down what information do I know and what information do I want to know. So do I know the ending amount? Yep, that's the bigger number always consistently. That is $14,494.08. Do I know my starting amount? Yep, that's the $5,123. Do I know my interest rate? No, that's exactly what they asked me for, so I'm going to just put a question mark. Do I know the amount of time that passed? Yep, 13 years. And I'll go ahead and put my units too, just because I'm being an extra great student. All right, now let's go ahead and rewrite my problem. So then we get $14,494.08 equals $5,123 E to the rate times time. So again, I want to try to get E by itself so I can convert this to a log equation and actually solve for my rate. So let's do that. How do I undo multiplication? Division. Go ahead and do your division. If you notice by now, I'm doing the same process over and over again. So let's go ahead and take out our calculator and we can calculate this guy out. So we can take $14,494.08 divided by $5,123. We get 2.829217255 equals E to the R times 13. Again, I'm going to go ahead and flip this around just so it looks like how I'm used to. E to the R times T equals 2.829217256. Disgusting number. Let's go ahead and first, last, middle this guy. First, natural log of last. 2.829217256 equals the middle, R times 13. Let's take the natural log of this guy. We get 1.040. The zeros just keep going, so I'm just going to leave that as is. R times 13. Now last step, just go ahead and get R by itself by dividing by 13. You've got an Algebra A problem at this point. Divide by 13. So we get R is 0.08 with a whole bunch of zeros afterwards, so I don't care about that. Just leave that as is. And then again, how do I convert this to a percent that I'm used to? Multiply by 100, you'll get that that is 8%. Or if you're good at looking at the decimal and converting to a percent, even more power to you. That's a good life skill. Alright, so let's put this back into the context of the problem. What is the interest rate of the account? The interest rate of the account is 8%. There we go. Alright, if you need to pause, write this down, go ahead and do so. Alright, moving on. Again, pause the video, try it on your own, and then we'll do it together. Alright, so we got Nicholas invests $6,757 in a retirement account with a fixed annual interest rate of 5% compounded continuously. How long will it take the account balance to reach $15,808.99? Alright, so let's go ahead and define my variables. Again, this is a step I will require. So we get that what is my ending amount? Bada boom, that is $15,808.99. What's my starting amount? That is $6,757. What's my interest rate? 5%, which as a decimal is 0.05, which again, you can always divide that by 100 to figure out. Time? I don't know time. That's my question mark. Now, if you find that all of a sudden all 4 variables are defined, go back and check the problem. If it's a math problem, they're not going to define everything for you. If it's a real life problem, maybe they will. Typically, you're solving for something, though. All right. So we get A equals PERT. So we get our ending amount, $15,808.99 equals starting amount, $6,757. E to the 0.05 times unknown t. Again, you want to get your exponent by itself. So let's go ahead and start doing that. Divide both sides by the number that's being multiplied by the exponent. Easy peasy. So let's go ahead and do that division. My phone is taking a moment. Intermission, there we go. Okay. So we do $15,808.99 divided by $6,757. So we get 2.33964629, disgusting number, equals e to the 0.05 times t. Again, I'm going to go ahead and flip this around to the order that I'm used to. And now I go ahead and do first, last, middle. Natural log first of last, 2-point disgusting number of infinity equals the middle, nice even 0.05 times t. Let's go ahead and take the natural log of this guy. We get 0.849999 going on forever. 76 equals 0.05 times t. Go ahead and divide this disgusting number by 0.05. We get t equals 16.99999 blah 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 going on to infinity. You know you can go ahead and round that guy up. He's a day off from being 17 years. Just round him up. 17 years is t. Now let's put it back into the context of the problem. How long will it take for the account balance to reach that? It will take 17 years for the account balance to reach $15,808.99. And now you're done. So remember, if you're solving for rate or time, you've got to try to get your exponent by itself and then apply your knowledge of E equations. Go ahead and write that down if you need to. Good luck. I'm sure you will do well.